Next topic in this chapter is physical properties of amines. See, amines exhibit hydrogen bond because in amines hydrogen attached with nitrogen, so they can form hydrogen bond, so they can exhibit more boiling point, more solubility in water. As the size of the alkyl group increases, solubility decreases. Solubility of amines decreases. We know that very well. Next, alcohols have more boiling point and more solubility than amines due to more polarity of OH bond. Alcohol here point is regarding alcohols and amines both exhibit hydrogen bond, but compared to alcohols, amines exhibit less boiling point because oxygen having more electronegativity compared to nitrogen, so its polarity is more, then it forms more attractions, automatically boiling point will be more. So what is the point? Alcohols exhibit more boiling point compared to amines. That is about physical properties. Next, chemical properties. First chemical property is with acylation. Acylation means when amines reacts with acetyl chloride, then we get this compound C. When this HCl will be removed, then we get N-alkyl estimide. When methylamine reacts with CH3CCl, then we get this compound, that is N-methyl estimide. Next one, excess of alkyl halide. When primary amines reacts with alkyl halide, then we get secondary amines. When this secondary amines again reacts with one more alkyl halide, then HX will be removed, then we get tertiary amine. When this tertiary amine reacts with one more alkyl halide, then we get quaternary ammonium halide, that is R4N plus X minus. When primary amines reacts with alkyl halide, we get secondary amines. When this secondary amines reacts with alkyl halide, then we get tertiary amines. When this tertiary amines reacts with alkyl halide, then we get quaternary ammonium halide. This is the reaction with alkyl halide. Next, with hydrogen halides. When amines reacts with hydrogen halide, then we get addition compound, that is RNH3 plus X minus. If you take CH3NH2, then you get CH3NH3 plus X minus. If you take C6H5NH2, then you get C6H5NH3 plus X minus. That is about reaction with hydrogen halides. Next one, carbyl amine reaction, that is also called isocyanate test. This is also one of the important reaction because that is named reaction. See, when amines reacts with chloroform and NaOH or KOH, when primary amines reacts with chloroform and NaOH or KOH, then we get alkyl isocyanate. It is having unpleasant odor along with KCl and H2O. So what is the point here? When amines reacts with chloroform and NaOH, then we get alkyl isocyanate. This is the preparation method of isocyanates. This is the test for primary amines. Only primary amines gives this test. Aniline also can give isocyanates. Secondary amines and tertiary amines cannot react with CHCl3 and KOH. Next point, with Hinsberg reagent. Hinsberg reagent means C6H5SO2Cl, that means benzene sulfonyl chloride. Benzene sulfonyl chloride is called Hinsberg reagent. When benzene sulfonyl chloride reacts with amines, then we get C6H5SO2NHR. This is called what? N-alkyl benzene sulfonamide. When benzene sulfonyl chloride is that is called Hinsberg reagent. When it reacts with primary amine, then we get N-alkyl benzene sulfonamide is formed. It has acidic nature, hence it can react with the base. See, this is the corresponding reaction. This is benzene sulfonyl chloride. When this compound reacts with secondary amines, then also we get one compound. This is the reaction between benzene sulfonyl chloride and primary amines. This is the reaction between benzene sulfonyl chloride and secondary amines. This is the reaction between benzene sulfonyl chloride and tertiary amine. Here you have to remember one point, that is benzene sulfonyl chloride can react with primary amine as well as secondary amine, but it cannot react with the tertiary amine because there is no hydrogen attached with nitrogen. Next point, after reaction with the primary amines, it forms N-alkyl benzene sulfonamide. It is having acidic nature because one hydrogen is present on nitrogen. It is having acidic nature. Here there is no hydrogen on nitrogen. After it formed when benzene sulfonyl chloride reacts with the secondary amine. So what is the point here? This compound can react with the base because it is acidic compound. How can we say that this is acidic compound? Because hydrogen attached with the nitrogen. But here there is no hydrogen attached with nitrogen, so it cannot react with the base. This compound cannot react with the tertiary amine. From these 3 points we can say one point, that is this Hinsberg reagent is the distinguished reagent, nothing but identifying reagent of primary, secondary and tertiary amines. This is very important point. By using Hinsberg reagent we can identify whether it is primary or secondary or tertiary. How can we identify? When Hinsberg reagent reacts with primary amine, then this compound will be formed. This compound can react with base. When Hinsberg reagent reacts with secondary amine, then this compound can be formed, but this compound cannot react with base. When we take tertiary amine, that cannot react with benzene sulfonyl chloride, nothing but Hinsberg reagent. From all these 3 points, what we can say? Hinsberg reagent is a distinguished reagent. That is these 3 points regarding identification of primary, secondary and tertiary amines. You may get one more question regarding this one. The questions may be, how to identify secondary amines? How can you write? What we have to write? When secondary amines reacts with benzene sulfonyl chloride, then we get this compound, that product cannot react with base. Like that we can identify secondary amines. How can we identify primary amines? When benzene sulfonyl chloride reacts with primary amines, then we get a compound that product can react with base. In case of tertiary amines, no reaction. These points indicates about these 3 reactions. Next, electrophilic substitution reactions in aniline. Now the reactions of aniline, aromatic compounds. Till now we saw the reactions aliphatic regarding aliphatic amines. Now aromatic amines. See, first reaction is nitration. See, this is a special reaction. When aniline reacts with HNO3 and H2SO4, then we get 3 types of products. They are para-nitroaniline, orthonitroaniline and meta-nitroaniline. This is electron donating group. When electron donating group present on benzene ring, then we get 2 products, because incoming electrophile attack at ortho and para portions. But here in this reaction we get one more product, that is meta product. Why we get meta product? Initially in this mechanism NH3 plus will be formed. That means this H plus going to react with this one, then NH3 plus will be formed. That NH3 plus acts as electron withdrawing group. After that H plus will be removed after forming this product. That due to the presence of NH3 plus, this incoming electrophile attack at meta portion. Because of that reason this will be formed. So in this reaction 3 products will be formed. Here this is major contribution, that is what? Para. After that meta. This is very less contribution, that means chances are very less, 2% only will be formed regarding ortho. That is about electrophilic substitution reactions of aniline in case of nitration. Next one, sulfonation. Sulfonation means reaction with sulfuric acid. When aniline reacts with sulfuric acid, then we get this compound initially, that is NH3 plus HCl4 minus. That means how one H plus is going to attack here and HSO4 minus is also combines with this part. Then NH2 becomes NH3 plus and HSO4 minus. That means this additional compound is formed. When this compound undergoes heating, then what happens? H2O will be removed. That means one hydrogen from this position, and one oxygen from here and one H from here. I repeat that point, listen carefully. When this compound undergoes heating, one hydrogen from this position, one hydrogen from this position, and one oxygen from this position will be removed as H2O. Then SO3H will come here. Here NH2 will be left. Finally, again this can be reversible. That means this H plus come and go attack here. Then NH2 becomes NH3 plus. This is called deuterion. Why it is called deuterion? Deuterion means if positive charge and negative charge, both charges present in a molecule, that is called deuterion. That is also called dipolar ion. That is about sulfonation reaction. Next one, with the acetic anhydride. Acetic anhydride formula is what? CH3CO twice O. That is called acetic anhydride. When aniline reacts with acetic anhydride, then CH3COH will be removed. That means CH3CO, this O, one OH. Then COCH3 here, which will be left, COCH3 will be left. That comes and attack here. Then this compound will be formed, NaHCOCH3. When this compound treated with nitration, HNO3 plus H2SO4 means what? Nitration. Then we get this compound. That means this compound acts as electron bonding group. Then incoming electrophile attack at para position. This ortho compound is not possible because of repulsions. Then we get this compound. When this compound was treated with water, then acetic acid will be removed. That is CH3COOH. Then finally we get this compound, that is para-nitroaniline. And that is about reaction with acetic anhydride. Next one, with the bromine water. When aniline reacts with bromine in the presence of water, then we get tribromoaniline. That is nothing but 2,4,6 tribromoaniline. That means one bromine attack at ortho, para and ortho positions. Bromines attack at ortho, para, ortho positions. Then we get this compound. That is called what? 2,4,6 tribromoaniline. Here one more reaction is there. That is when aniline reacts with acetic anhydride, like as in previous reaction, then we get this compound. This is called acetonylide. When this compound reacts with bromine in the presence of ethanoic acid, then we get which one? This one, parabromoacetonylide. When this compound treated with water, then this will be removed and this will be formed. That is what? Parabromoaniline. Here you have to remember one point, that is when aniline reacts with the bromine in water, we get tribromoaniline derivative. When aniline reacts with the bromine ethanoic acid, then we get parabromoaniline. These 2 points are very, very important points. That is all about chemical properties of aniline.